This morning, I'm gonna take care of the safety video, and it's more or less, it's not really a safety video, but anyway, I'm gonna share my screen. But guys, the video I'm gonna show you is kind of, well, it's called The Life of a Lineman, or A Day in the Life of a Lineman. This is what you can expect. Of course, this is done up north where it's very cold. So you may have to go up there and work some, depending on where you go work. But anyways, if you would, look at the video, watch it. And if you see any things that you think may be safety issues, safety violations, just make a note of it. And when the video is over, let's talk about them, okay? So I'm gonna share my screen. Here. Share. Got it?
Yep.
Yeah.
Yeah.
Being a lineman, you have a special bond with your coworkers, almost a brotherhood, because you have to place a higher level of trust in your coworkers and get the job done safely and correctly. Hello. Okay. Yeah, I'll be ready. Anytime you're on call or you get called out, doesn't matter what's going on in your personal life, you pretty much have to drop it and go to work. Love you. Be safe. We have a pretty large area, so it could be a couple-hour drive time just to get to the outage. You have to assess the outage, see what's going on. Sometimes I think it takes losing your power for a time in order to appreciate it when it does come back on. Usually customers are very grateful to us for the work that we do and for the service that we provide.
Here we are in Jensen, got tons of snow. You can see Dennis out there, he's up to his knees.
The most challenging part of our job is the unknown sometimes, and sometimes it's climbing poles and working in extreme weather, extreme conditions. It is a dangerous occupation, but I get a sense of satisfaction knowing that I construct something or provide a service for somebody else. Actually started with Moon Lake reading meters actually, and the guys on the line crew, they would invite me to go with them, and I actually started liking it, and that's where the desire or the spark started to become a lineman. I always looked at my dad as a hero when he would go out in the middle of the night when most people are hunkered down. That's when he'd put his boots on and go to work. I remember as a kid watching my dad be a lineman and hoping that he could come home safely. And now that I have a family of my own and kids looking up to me, I keep that in mind everywhere I go. I've been a journeyman lineman for almost 5 years, and I've been doing line work for just over 8 years. Sons like to do what their fathers like to do, and I think that's kind of where the spark started for him, possibly. It does give me a sense of pride that my son has followed in my footsteps. I really enjoy the work I do, knowing there is a little bit of danger in my job. I take pride in knowing that we will go work in any weather condition, in any type of conditions that we have to keep the lights on.
What started for me was I love being outdoors. I wanted a job that I could be outdoors and enjoy nature and not be cooped up in an office. And this is a challenging job and very rewarding.
My husband is out there for everyone who needs those comforts of life that we have. My mom always jokes that it takes a long time for her to say her prayers in the morning because she names everyone on my husband's crew to make sure that they're safe every day that they go to work, and we do the same as well.
I admire my dad because he is brave and is risking his life to help other people get their power back on or something.
Some of the dangers we face, obviously working high voltage on a daily basis. We will work 25,000 volts pretty regularly.
I don't think people understand that most of the time when we are working, there is a danger within an arm's reach of where we're at. Any moment, if you take your mind off of the task at hand, you could get hurt or killed. A lot of physical demand is involved in it, but also know the safety that's involved, the training that's involved, and it's taken real serious. And so I feel that it's a good career to get into.
My husband and all the other linemen and their families are making the sacrifice.
It's pretty dangerous and it worries me sometimes, but I know that he's helping people and I like that.
Plan for the worst and hope for the best. Because you never know what type of a call-out situation you're going to have. It can be something minor, it can be something major, but you're always planning for the worst and hoping for the best. It's important to us to get the lights back on and to complete jobs and things like that, but number one on our mind all the time is make sure everyone gets home safely.
Which obviously is our most important goal as a lineman, is to return home.
We're grateful for the sacrifices that he makes for us every single day. And we just want him to know that we love him.
Wow, that video kind of says it all right there, and it does. I mean, that's really what you do, guys. I mean, from like you saw at 3:30 in the morning, the phone ringing and him getting out of bed, leaving his family, having to go put somebody's lights back on. I mean, that's what it is. If you all don't like weekend work or getting out to bed at all times of the night and morning, then this is not for you. Working in the rain, working in the snow, hurricanes, it's all conditions all the time. And these guys, just like any other crew around the country, they're doing it to keep people's lights on, and that's what we do. Couple things, and I think this may be the second time I watched this video. Did anybody see anything where they thought might have been a safety issue, or?
I did.
What'd you see?
They were using phasing sticks, I believe, on the lines. And no, I didn't see any rubber gloves on anybody in that whole video.
Did you see what voltage they were working?
I did not.
Is 25 kV rubber gloves. You're pushing. I don't know if he's talking 25 kV face to ground or 25 kV face to face, but if you're 25 kV on a stick, there's no rubber glove that will give you protection.
Okay.
So that's the transmit. I mean, good recognition of it.
Yeah.
But they're working it as a transmission voltage.
Right. Yeah. Everything that what you saw in our areas, if that was the case, I can tell you from a Duke standpoint, we used to years ago when it was dead and grounded, they allowed us to use leather gloves to work it, but That's changed through the years, got much safer. Even though it is grounded, dead, tested, grounded, we were still required to work with our rubber gloves on. So, but I think that's a good video. Of course, that's in kind of hard conditions where they're at and where they're working. We've been to many places where we'd have to work in conditions like that. So you're liable to see some of that, you know, when you guys go to work. Professor Shoemaker, you got anything you want to add to it, or?
Well, I mean, open it back up there. Did anybody else see anything else? The guys working and doing work out, it looked like outside a substation. How'd you like their uniforms?
Like I said, I didn't see any
Everyone on my
How's that?
husband's crew.
Sorry,
All
go
right.
ahead.
Go ahead and pause there. You can leave it right there. Now, it's kind of the situation that you're going to be working in Dale. If you're working around or with energized conductors, a uniform is required. But if you're working, and this is a good instance for it, say you're building a 5-mile line outside of a substation and everything is de-energized, a uniform is not required.
Mhm.
So a uniform is only going to be required, especially the shirt part. And I enjoy doing that, and the crews enjoy doing that. They've got a long piece of line that's not around anything that's energized. They leave their fire retardant pants on, and of course their boots, and they just change into a t-shirt or a long sleeve shirt if they were climbing. That's fine. That's okay to do, as long as you're not working around anything that could produce an electrical arc.
Yeah.
Anybody else say anything?
I want to make another comment about
I've got one more thing to add there too after yours.
when he got this guy got back home with his family. You can see, hey, I mean, he's got a nice house.
Huh.
He evidently got a really nice house. He's got a big game room somewhere. He's got all these games for his kids and his family to relax. But the most important thing is it's not just about you and your crew. It's about you and your family, what you're going to come home to, you know, because if you don't do things the way you're supposed to out there and you get hurt, then it's, and I said it before, it don't just affect you, it affects your family, and it affects your family for a long time.
Mm-hmm.
Okay.
True, 100%. I mean, some of you younger guys, you know, your plans are to be married or with your significant other out there. One is you will be the provider, and being the provider and being safe for your family is one thing. And then of course the love that you have for your family and your kids and whatever you have there, guys, you're going to leave a huge void if you're not safe. I know. Sorry for the mouthful of biscuit. I wasn't ready for that one. I know I've told you of my accident, and you know, I'm 20 years old. I've only been with the company for 1 year, and very close to death. In fact, I was dead for about 7.5 minutes. And you really don't recognize, even at your age, understood, I was married, about the impact that you're going to have, not only to the family that's with you, but to your parents and the community around you. So being safe is monumental for yourself and the family and loved ones around you. One more thing I did catch in the video, it was a big no-no. There is a flash of 2 guys riding in a truck together.
Yeah.
The passenger wasn't wearing a seatbelt.
Mm-hmm.
So I love to nitpick videos. So that's one thing that was going on. I mean, I doubt you'd be able to find it. It was so fast that they went through it. But good video.
Yeah.
And you know, I think right there at the beginning, one thing the guy said that was, you know, kind of narrating it there, when he said it's almost a brotherhood.
It is a brotherhood.
It is a brotherhood.
Exactly.
I can't think of any kind of camaraderie or relationships or anything like that that it goes on in a job that's closer than a lineman. And I've had some different jobs and I've spoke with some different people about it. I can tell you right now, if Robbie called me up today and said I needed this,
Same
I'd be
thing.
there for him because,
Mhm.
and I know he'd do the same for me,
Right.
you know, and I've known him for what, a year.
Yeah. Yeah.
So it's just a quality of the person, and you will make friends on crews. You will make friends in companies that anytime they're in need, you're going to help them. And anytime you're in need, they're going to help you. So
Yep.
it's something else. It is a great career to be in. All right. Anybody else have any other questions? Okay. I have got a video to share here because we're going to be coming up on it here pretty soon. It's kind of a hokey video, not really the best quality, but they do bring up some major points in here, and it's on substation safety. Okay, let's go here and here. Everybody see that screen?
Yeah.
Nope.
How about now?
It's coming up. Yep.
Okay.
So this is the substation 3480.
Yeah, substation I.
How many substations are there in Independence?
Just tell them it's 15.
15?
Okay.
So there's a gate, there's a
It's
enclosed wire gate.
So all of your substations, and this is an OSHA standard, must have a fence that's 10 feet high and must have barbed wire at the top.
It's an enclosed substation. The reason why it's enclosed is for the cosmetic value. We don't like them enclosed, but that's for cosmetics because of the general public.
Cosmetic, so that you don't have just the wire fence.
Right. You have chain link fence.
Alrighty.
Okay. So underneath the substation is what we call a grounded mat.
A grounded mat.
Okay, so what do you explain there? What do you call what's underneath the substation?
Grounded mat.
Mm-hmm. Typically under between 12 and 24 inches. And we called it a ground grid. There's ground wires that are under the ground and they form a mesh. And the mesh area, they're 24 inches apart. So there's a lot of copper in the ground. Then they're all welded together. It's what they call CAD welding. So they're all interconnected. And Santee Cooper also extended that to 10 feet outside of the fence. So why would we put a big old grounding mat underneath the substation?
Because there's a lot of voltage there. Tremendous amount.
It refers back to one of our first videos we had in ELW 110. Paul, you're partially correct. If anything in here falls to the ground, in a conductor or any of this bus or anything like that, what do we want to try to avoid while we're walking?
Making contact with the ground. Getting electrocuted.
Well, yeah, I mean, when you walk on the ground, you got to make contact with it. So I've not seen a floating person.
Is it something to do with static electricity?
No, remember the truck running into the power lines and the guy jumping out of the truck? What did he do?
Step potential.
Step potential. Mm-hmm. Now that I have a grid completely under the substation, under these stones right here, when I take steps across the substation, I'm at the same potential because I have a grid underneath me. It's like a grounding mat. And the whole station bed here is at the same potential, even if I take a step across it. So that's why we add a grounding grid inside a substation.
Underneath this rock?
Yes.
Okay.
What it is all kinds of copper lines running underneath there to take it to Mother Earth. You see, everything here is grounded. Every piece of equipment, every steel structure is grounded.
On
and it
concrete?
hits the mat. It goes down the concrete and into the mat.
And the mat is grounded.
The mat
copper.
is the ground.
That's the copper.
That's the copper.
Okay.
So not knowing, but when they cut this, okay.
Okay, so he walks in here and walks around. There's a safety violation going on here right off the bat. Take a look at this guy. What's wrong?
Doesn't have a hard hat, doesn't have safety glasses, doesn't have
Yeah.
gloves.
You have to have, and I like to call it the minimum PPE. You're gonna have to have fire retardant clothing on. You are in proximity of high voltages. You're gonna have to have your hard hat, safety glasses, and steel toe climbing boots on. Gloves are not required yet because you're not handling anything, but you have to have that minimum amount of PPE on. He has none.
Knowing, but when they cut this, okay.
Mm-hmm.
So the ground grid is underneath the substation. They also take and they come off for every structure that's in the substation. This is a steel structure holding an insulator. And what do they do with it?
They ground it.
So now the structure is at the same potential as the ground. Everything you want to be in the substation at the same potential.
When they cut it, if they
So what does it mean when they cut it? Any guesses?
When they turn the power off.
When you cut a ground, you're not turning power off.
will get on this end,
See this piece of copper right here? How much do you think it's worth? Take a guess.
50 cents. It's up to the market.
It's up to the market. Now, I'd say there's probably, you know, in looking at that piece and the size of the wire, it's probably around $2. All right, because power companies use high quality copper right there. And let me get back here. You think of every piece of that sticking out of the ground to every single structure, plus they have it going up higher on some structures. What do people do?
They like to
Steal it.
steal
Or
copper.
Yeah.
take some scrap.
Yeah, they'll take a shovel and they'll get over on that wood side. You saw the side of the substation was in the woods. They'll dig under the fence. They'll take a set of cutters and they'll steal all the copper out of the substation. Very potentially dangerous. Professor V, we tried some preventative measures. Is there anything you guys tried to do in substations for people stealing copper? He must have stepped away. I'm on the share screen.
It just lagged out, or they kicked him out or something like that. He said he
Okay.
left.
Okay, we'll carry on.
they will get on this end and this end, it will kill them.
So what does he say? What will happen if it gets cut? He just said it.
If
He said it'd kill him.
they will get
Right. There is the potential there that if I cut this ground wire, hold one end, and then put my hand on the other end, you've got a difference in potential now because you've made a cut in the wire, and there is the possibility of getting killed by doing that.
on this end,
And yes, we've seen this happen to people in substations, thieves.
and this end, it will kill them.
Okay, if they were to get on,
If they grab here
right?
and here and cut that out of the middle, the
Oh.
electrical, because that
How much, when they do that, how much does that copper cost to replace it?
copper itself, the price of the copper is not very much. Like a 2-foot piece is probably $20, but
Wow. Did you see what he said? Hear what he said? 2 feet
20
of this,
bucks?
2 feet of that's
20 bucks ain't that much.
This is 2016. I wouldn't say it was that much. There is more copper. I mean, it is solid copper in a substation. You're not going to use any copper clad or anything like that. You're going to use the high quality stuff. And this is 2016, so the prices might have been a little bit different. But you can, and I've seen people do it. We've got our own, you know, investigative police, just like the campus has its own campus police that go out there, and you can make a lot of money off this.
The labor involved, or the other thing is involved, if we had a lightning storm or of course a human being grab it, then we'd have a lot more issues.
So there's that case I was showing you right there. Look how long this piece is. It was way up there.
But if lightning got in the substation without that protection, that it could destroy all this equipment.
And this equipment is millions in dollars, right?
Yes. Now that transformer right there is about 1.5 million.
So the 3 green big boxes,
The 2 big green ones are about
1.5 million.
Yep.
How many voltage you say?
69,000 volts.
69,000 volts just from this one substation. And how many substations does Independence have?
15.
15. That's a math question.
What we have here is switches. These are switches. These here are breakers that you can open and close to isolate. Them are lightning arresters up there in case lightning gets into the substation. It goes through them. It goes to ground.
Oh, I see.
The big canisters on top are across that side. We're called lightning arresters. If lightning gets into the substation, the lightning hits that and it takes it to ground. They cut the ground off at the ground. It has no place to go, and that's why it blows everything up.
And that's why people then we wouldn't have electricity, plus it costs so much money for the taxpayers.
Well, they're still in the copper, and it leaves the substation exposed. These are all cooling fans, which they steal them too. They steal the control cables, which causes the transformer to overheat and go bad or kick out. Interruption of electricity.
And do they know what they're doing when they come in here? Do they understand the risk?
No, they do not understand the risk.
They do not.
Things they do that a qualified person would never do.
Well, that an intelligent person would never do. Qualified or intelligent, right?
That grounds the fence.
So even the fence is grounded.
Anything metal is conductive.
So they'll take, and that's why we ran it outside of the substation. You'll take your ground grid and just run it out to the edges. And you'll notice what they do with the fence. All the fence posts, each joint of pipe in a fence is grounded, and the barbed wire is actually grounded also.
So even the fence is grounded.
Anything metal is conductive.
So what if they were to come in and cut that off?
Then there's a risk of someone touching the fence and getting shocked. Probably not enough to kill you, but enough to get you shocked.
So do you think they could get that? They couldn't really get that off because without being shocked, could they?
That's what I say. If you take this, and cut it, and you grab the other end, you could be the conductor.
Yeah. Well, and those things that are attached to the barbed wire.
That's called split bolts.
Yeah. So it's not like you can cut it off in. I guess you could cut it off in pieces, but.
They do it every day.
Really?
Yeah.
Dumb people. Okay. Wire.
All this shit is there's one other thing that's kind of funny. Besides, you got the human contributor to all this fault, for electricity to fail. You also have the internet and cyber. You can attack these places because they can hack it. And there's one other thing that gets to electricity.
What's that?
Squirrels.
A squirrel.
Okay, so that pretty much goes over what, as far as the importance of grounds in a substation and the need for grounds and what their purpose is. Is there any questions there? All right, you guys remember doing the transformer change out in my poles out in the yard?
Yeah.
Yeah. Why don't I run the pole ground all the way down to the ground? Why don't I run the pole ground all the way down the pole like it should be?
Because people's going to try and steal it.
Yep. I mean, it's been stolen so many times out there at that field. It's pitiful. So that's why I don't run it all the way down to the ground. And you know, it happens. It could happen rather quickly. It's inherently dangerous to the public if they do try to do it. And you guys, it's also, you know, something to keep in your factors. You always de-energize something. If you have to cut a ground or remove a ground, the equipment that you're working with has to be de-energized. So if they were to go in that substation and have to do any work, these are not the droids you were looking for. Is somebody talking? Anybody tell who that is?
It might be Briggs. He usually has the issue with backfeed.
Yeah, yeah. Whoever's trying to talk there, you're really, really bad. I can't understand what you're saying. So anytime that you have to cut a ground, say for removal or say splicing or anything like that, the equipment that you're working on has to be de-energized. So if we had to go up in that transformer pole and the transformer change out and cut that ground, everything from the primary down must be de-energized before you cut a ground. Any questions? Okay, good information this morning. I like V's video. I hope you liked mine also, and we'll get carrying on with business right here. I am moving over to the book. I'm on page 302 of our books. I'll give you just a moment to get those out. While we're waiting on that, I will talk a couple of administrative things here that were going on. I have got to, and I think Professor V has got some also, we have got to re-enter that quiz 2. We did tell it to go ahead and migrate over to the grade book. It did not, so we're going to have to re-enter those grades in the grade book. For most of you, I think about 90% of you, great improvement on that one. And you know, you did well. A couple still scored low, but they at least passed. And I only had one person for some reason that didn't take it at all. So that will be a 0. The other part is the presentations we are going through. Do understand it takes a little time. We got to review each one of those, and those will be posted soon also. The guys that were out of the field yesterday, everybody showed up at the field yesterday and did your 3-phase and single phase, identify, isolate, and restores. Those went well yesterday, and those grades will be entered today for my class by me, and Professor V is working on his also. That will show up as a quiz grade. So thank you very much for getting that done. Okay, we're into the book. I'm on page 302. 2 types of underground distribution systems. Now, I don't like the way they term this, so be advised. The 2 main types of underground distribution are duct and vault systems and the direct bury system. Now, what do they, as far as you know and can think of, what do you think duct and vault is?
Conduit and enclosure.
Yeah, you know, it's going to be, I mean, who plans on working in a big city like Chicago, New York, Los Angeles? If I was working in a metropolis area, I would probably be calling it duct and vault system. You're going to have duct in the ground, which is PVC conduit. Typically, those are encased in concrete due to travel over the top of them. And then every so often you're going to have a vault, and that's what they're showing in figure 9-1. Now, vaults can have splices. Vaults can have elbow terminations. Vaults can have transformers. I mean, pretty much is what they call subsurface underground. Everything is under the ground. They don't even have the same kind of situation that we have out on our field, where we see equipment above ground. All of their equipment is below ground, especially in high population cities. Now, I'm going to add another piece onto this. What we call ours in Santee Cooper, we're not a metropolis. You know, we got Myrtle Beach and Conway and all those areas and whatnot. And Duke's the same way. Now, Duke might have some big cities, but we're the same way. We call it cable and conduit. So what we'll have here is cable and conduit and all of our equipment as far as transformers, enclosures. Now, where do we place it? Above or below ground?
What was the question again?
You know, what we call our system here at Santee Cooper, and Duke's got a good portion of it. Most utilities do is we put cable in conduit. So we install conduit, put cable in it. Where's all of our equipment? Is it subsurface? Is it below the ground? Or is it above ground?
It's above ground.
Yeah, it's above
part
ground.
above.
So what we'll do and what we'll call that is pad mounted equipment. So we've got transformers, enclosures, secondary enclosures, switch gears is above ground. All right. And the next part that they call here is and the direct bury system. Now, what do they mean by direct bury? This is for conductor only.
That's straight cable, not in conduit or PVC.
Yeah, yeah. That is that's pretty much fading away almost completely. Almost all.
Lineman says they do straight bury cable.
What was your comment, Paul?
Mr. Verman said that his old company do straight bury cable. They don't put it in conduit or nothing.
Yeah, I wish he was here. He could speak on it too.
Yeah.
It totally depends on the situation here. And a lot of companies will go into cost analysis. Obviously, if I put wire directly into the ground and I don't install conduit, is there a money savings?
Yeah.
Yeah, obviously you don't have to pay for the conduit. Okay. If I have a failure at any time into the future, how much does it cost, do you think, to replace one span of conductor in conduit compared to splicing?
Probably less.
Yeah, I can pull a piece in a piece of primary or secondary in a conduit in a much shorter amount of time, terminating on both ends to be finished. Digging and splicing is going to take a lot more labor.
Yeah.
Splicing is going to take a lot more labor and time, and we're going to have some videos on some elbow terminations and splicing terminations. And another part that you need to keep into your minds right there, we had a policy that in any line, this is overhead or underground, you are not permitted more than 3 splices, no matter what your span length was. So if I have a 100-foot piece of secondary that's feeding into my house, I cannot have more than 3 splices in it. Any reason why you would think that?
Does it weaken the
Resistance.
Right. Right. Every time you add a splice, you're adding resistance to the conductor. It's not as true as the actual conductor straight through. And then, you're really not doing much for your system. That system is not going to be as viable as it was before. On underground, if I go to the 3rd splice and it fails again, what do I need to do if the cable's not in conduit?
You have to dig it up. Replace it all.
I've got to do a full replacement now of that, and you have to take out the old base. It's not easy. So that'll give you some information of why cable and conduit is becoming much more popular, and direct bury is not. All right, the duct and vault system is used in cities and streets and sidewalks we had talked about before, and lack of space would be impractical for a direct bury system. So that's why you're using duct and vault. Okay, I'm going to go down below the picture. The direct bury system is more economical to install than a duct and vault system, and is mostly used in, remember this term, this is going to be a question on a test, underground residential distribution. We're going to ask you, what does URD stand for? And it stands for underground residential distribution. Now there's a word in there that kind of throws some people off. It's the middle one, residential. Now, if you were to take this term underground residential distribution, where do you think it applies out there in the world?
Homes.
Homes, subdivisions, absolutely. Great comeback on that. But let's take the college, for example, in the college campus. There is a lot, and I'm going to go ahead and say the word, URD installation out there. Is it a residence?
No.
It's not. So we use that term to apply to not only residential homes, but any underground install that we do out there for a customer. Okay. The college is encompassed for all buildings with underground residential distribution feeds, but there are no residents out there. So don't take that term residential as an absolute.
How would commercial distribution apply then? What would
There is
that
no such
represent?
thing as a commercial and I'm trying to get you to know the term and where it applies. There's no underground commercial distribution. There's no UCD term.
Oh, okay.
Okay. They always just use the URD term. I just want to keep you, advised. If you go down to Ocean Boulevard, where it's been converted, all of the boulevard is either business or hotels. They're not actual homes. That's all URD. That's an all new URD install. There's no residences there.
So more than a good way to explain it is kind of like high traffic areas, I reckon. Get it most of the time.
Yeah, it gets it most of the time. I just, I don't want, you guys are asking good questions. I don't want you to get your heads locked into a term that if you go out to Coastal Grand and start doing some work at Coastal Grand and the guys say, yeah, we've got a bad span of URD primary out there. Well, Professor Shoemaker told me URD stood for residential. It encompasses that Coastal Grand also.
Gotcha.
Okay. Yeah, URD installed. Don't limit yourself to residential because it does encompass commercial systems also. Okay. Know the term though. Know what the URD stands for. For our discussion, the direct buried system includes cable buried in sand, in big O pipe, or in PVC pipe. Now, this is where we're going to differentiate right here from the book. Direct bury to us was cable into the dirt. That's our terminology. I've gone to New York. I've gone to Florida. I've been to Louisiana. I've been to Texas and spoken with all of those systems. I've spoken with companies here that are local. If I say the term direct bury, Paul has said that before, I'm taking the conductor and putting it directly into the ground. All right, the book differentiates from that somewhat. They're saying that you're actually putting the cable in pipe and then into ground. That's not the case. All right, putting cable in pipe and then put it into the ground is called cable in conduit. So I want you to remember that. That's why I'm going to not 2 types of underground, I'm going to 3 types. There's direct bury, cable into the dirt, no protection. There's cable in conduit. That's where I install conduit and I install conductor inside that conduit. And then there's the duct system. And I'll bring up a picture of a duct system here pretty soon. That's cable in conduit encased in concrete. And I'll show you a picture of that. Stand by just a moment.
Duct system?
Sir?
The duct system?
The duct system, yes. I'll show you in just a moment. Here we go.
It's on the next page in the book.
It is. I want to show you some of these pictures here because some of them are really kind of cool. Yep, it is.
So that whole run of conduit would be in concrete, the whole thing?
Yes, the whole thing would be encased in concrete.
Oh, wow.
All right. Well, hold on with just one moment. I'm going to show you some other images that are going on here. Some systems that they have built out there, you actually take the whole section and put it in at one time. Some you have to install it in the ground. So let me get an open image, a new tab. We'll take a look at this one and then we'll take a break here. So share screen on. Okay, there's a great example right there of a duct system. Now, once they have got all this conduit in and complete, all of this is going to be encased in concrete.
That's crazy.
Okay. Now, Sir?
Why do they do that? That
What?
extreme.
Down a street, for one, it is a great protector of all the conduits. Two is this is in high extreme traffic areas where you're going to have, you know, heavy equipment, a lot of traffic. And really, when you install it like this, another thing, it's never going to get dug into,
Right.
nor drilled into before again. So you've really got a system in there that's going to last forever.
Looks like a headache.
Huh?
That looks like a headache.
It gets tough. The headache comes in where you need to identify each pipe and know which phase you've got in each pipe. That's where the fun comes in. All right, so that's the cable, that's the conduit duct system. Now, surprisingly, I've got a picture right here that shows cable and conduit. Where's it at?
Above it.
Right, that's cable and conduit. There's none of these duct racks that they're racking the conduit with. It's not encased in concrete. So they've actually got a cable and conduit system that they went under right here that's going in this direction. So that's conduit just thrown, and I'm being literal here. You're gonna put it together on the side, up on the ground, and you're gonna throw this into the ground. 2 or 3 sections at a time. And it's just gonna lay in the bottom of the ditch. So that's what you see is going on in this crossing right here is cable and conduit. Duct system bottom, cable and conduit above. Then the last one we were talking about, or the other one we were talking about, was if I just put wire directly in the ground right through here, don't use conduit at all. That's what we call direct bury. You okay?
Yep.
Okay. All right. That brings us to this point right here. Let's take about 10 minutes, guys, and we'll be back at 10 o'clock. Let's take a little break. So I am on page 304. Now, do a recap for what we just talked about in the last session there. On 302, it gives 2 types of underground distribution systems. There's really 3. They give 2 types here in the book. One is more of a metropolis type situation, and the other is a rural type situation. And there's another one that's kind of like in between, and that's the one I talked about. So the 3 types that I want you guys to know are the duct bank install and what it's comprised of, the cable and conduit install and what it's comprised of, and direct bury. What do I mean by a direct bury? So that's going to come up later on a quiz. Moving over to page 304, in that diagram right there, they just show a diagram of a typical duct type system. Now you'll notice the utilities, as far as electrical, where is electrical placed? Bottom, middle, or top?
Repeat that.
Look at figure 9-4 on page 304 and look at the placement of conduits right there. Now, as far as utilities are concerned, you'll notice you got concrete base in the blue pipes. Then you've got communications cables in the green pipes. Where is electrical always installed? At the bottom, middle, or to the top? Bottom. Electrical is always the deepest, or at the bottom of the trench. And this is a duct type system. It's encased in concrete. We'll see another figure here in just a moment. So that is always placed at the bottom. Then you're going to have gas, and then you can have communications, which includes telephone and TV cable, also sharing, and this is what they call a joint trench. So joint trench means all the utilities are using the same trench. Now you're typically not ever going to see, only in rare cases, water and sewer in the same trench, and that's if you have a limited space. So sometimes you might see it. You might have to dig down beside it to do your install, but in limited instances, water and sewer can also be in the same trench also. Okay, I'm moving over to page 305. This is something you guys are going to need to know, and it will be a question that will be asked. Look at the table at the bottom of page 305. Know what the colors are for your respective utilities. Now, what is power? What is electric?
Red.
What is gas, civil, gas, oil, and steam?
Yellow.
What is orange?
Communications cable.
Right. Blue,
Water.
green,
Sewer.
purple,
Irrigation.
white,
Proposed excavation.
correct, and pink.
Temporary survey tape.
Okay. This is mostly used by the SC 811 or whatever state you're in the 811 service. So when you see markings on the ground and you have a red marking, you know you have electrical cable beneath. Yellow, orange, red, green, purple, whatever you see down there through the rest of the list. Some utilities and some conduits, this is getting popular, go ahead and install their conduit in a pipe that has the same corresponding color. So I know you've seen some underground conduit out there that some conduit that's installed for electric has a red stripe on it. That denotes electricity. Gas companies, now they're going to use metal or a PVC pipe. A lot of their PVC pipe is yellow. Communications, a lot of communication companies are moving to this. The conduit that they install is going to be orange. Water companies, I don't know if you've ever seen a water line in the ground. Do you ever see a blue water pipe?
Yeah, they're big thing.
No, they're black. Okay, they're black. Now you might see some in PVC that are huge that are blue pipes, but all the taps that go off to your house are black. All right, green for sewer. In some cases in PVC, you will see green sewer lines. Purple irrigation, there is no purple irrigation conduit line. White, well, what do they mean by white proposed excavation? Look at the term for what it says. What does proposed excavation mean?
They're about to put something there. You think?
You're about to want to have something put there. It's a good way to put it. What's happening there is you've called and say you're at your house and you've got this nice brand new cedar tree that you want to install. And this is really a primer or a reference for the locator that comes out there. If you put a white mark on the ground, say a big box area where you want your tree to go, then the locator, all he has to do is come to that area and say, yep, this is where the guy wants to plant the tree. I need to locate exactly in this area. So it's used on smaller cases. Now, if I have a subdivision where I need to do a locate, am I going to go through the whole subdivision and put white paint down? That's impractical. It's used for more than, like smaller cases. Say I need the highway department needs to install a street sign or a traffic light pole. This is where I'm going to put it. So I'm going to mark the ground with white paint. The locator is going to come from the 811 service. He's going to look down and say, yep, this is where the guy wants it. I'm going to locate in this area. So that's proposed excavation. Purple irrigation, white proposed purple irrigation, white proposed excavation, and pink typically is either a pink marking on the ground for a survey marker or a pink flag. You know how surveyors like to put a pink flag into the ground to show a survey mark. Okay, I moved over to page 306. Now we've moved away from the cable and duct system. You notice that was in concrete. And the figure 9-6, what kind of install is this? Is it in duct? Simple question. Is the cable and conduit in duct?
Yeah, no.
Yeah, look at 9-4. That's cable and conduit with a duct system. It's encased in concrete, and that's duct bank at the bottom. On page 9-6, They just have a conduit installed into the dirt. So that's question.
I thought you said, is it inductive like?
No, in duct.
I get you now.
Okay, good deal. All right, so then one on page 306 here is we got cable in conduit, but there's no concrete, there's no racks or anything like that that's holding the conduit together down through the trench like you saw before. This is cable in conduit. And it says in that sentence, proper spacing between utilities is in utilities in a joint use trench. Well, first, the question I'm going to ask is, what is joint trench? We just talked about it before on the previous page.
Shared utilities in the same trench.
Excellent, excellent, Briggs. All right, shared utilities in the same trench. What do they mean by proper spacing?
That each utility has the proper spacing in between the other utilities lines.
Excellent, excellent. Thank you very much, Briggs. All right, there is a rule here that you got to follow as far as the proper spacing between utilities. And obviously, this is a nice, pretty diagram right here of where they're able to do it. It's not going to be exact. Between utilities, any utility from one to the other, you have to provide 12 inches of spacing. That's between utilities. Now, if I've got power and electrical, I can bundle all my stuff together. That's okay, both primary and secondary. But as soon as I add communications, I have to be 12 inches away. And if I add a gas line, I need to be another 12 inches away from the communications and the gas line. And the communications needs to be 12 inches away. So you would be thinking here, well, my trench is going to be getting deeper and deeper and deeper just to provide spacing, right? Right?
Yes.
Okay. You don't really have to follow it as far as vertically. You can get this 12 inches of spacing also horizontally. And you'll notice in the picture how they're spacing down low. The gas line is on the right-hand side of the ditch. Where's the telephone and TV cable? Left-hand side of the ditch. So you're able to get spacing of 12 inches between utilities, both horizontally and vertically. That's how you're going to be able to save on trench depth. Okay. All right, I'm down to the next paragraph down there on 306 at the bottom, pulling and laying cable. Now, it goes into a paragraph of maximal allowable tension and bending radius and estimated pulling tensions. Guys, those are going to be provided by an engineer. You really don't need to worry about those situations right now. The conduit that you're going to be using, and I've seen this happen before, you're going to be using what they call long sweep elbows. So the elbow conduit that's in the ground, you're going horizontally underground and you want to come up at a location. They use long sweep elbows, so you're not going over the bending radius. I have seen some people install conduit in the ground and they've used a plumber's 90, and I don't know if you know what a plumber's 90 is. It makes an immediate turn. Essentially, you can't get cable through that. It just won't make that bend. So you don't have to worry about pulling tensions. Those are included on the work request that you're going to be getting. You just have to abide by those tensions that are on there. Preparing the duct. Typically, a duct will contain a pulling wire or rope. Never used it. Some companies, what they will do is they'll have a conduit that has the rope or the pulling wire already pre-installed in it. We never used it. We installed our own string and rope after we installed the conduit, just as it goes on. If not, an air compressor can be used to blow a carrier, a bird, we used to call them a rat, with a small nylon cord attached to it through the duct, through the conduit. The cord is used to pull a bigger rope, which in turn brings in a bigger turn page, pulling rope, or a winch line. Another method pushes a duct rotor. That's in figure 9-8. From one vault to the other or through the conduit. One way a duct can be checked for proper diameter through the obstructions is to pull a flexible steel mandrel for the correct diameter through the length of the conduit. We typically never did that either. What we do is we would take the rat or the duct bird, as they call it, and we would actually blow that through the pipe a couple times to clean the pipe out. And then we would go ahead and blow our strings in. Now, there are tons of other methods out there, and this is probably something that you're going to be going by and abided by the utility. Let's talk about the rotor first. The longest rotor that we ever had was 200 feet, and it was cumbersome to work with. It's a fiberglass flexible rod that you just push through the conduit, pull your string back, pull your ropes back, then pull your conductor in tied to the rope. They're not that easy to work with, and they're relatively good on short runs. One of the more useful methods and the easiest methods in here, especially when you're working with underground services, is to take the conductor itself and just push it through the pipe by itself. Instead of using the rotor, just push the conductor in by hand. That's good for short runs. I would say, depending on conductor size, you're probably up to about 100 feet. You can push conductor in. All right. They've got more into the book here, rigging the pull, making the pull. So they really get into pulling stuff here. Our method at Santee Cooper, and I've seen it used many places before, if you don't want to use the blower, if you don't want to blow in a rat, if you don't want to push a rotor, is during the initial conduit install, conduits in 10 feet sections, it just run a string through each section of conduit as you install it. So I've got my first piece of conduit, I put a string through it. That string is on a box of nylon rope at the end. Put some conduit together, run that string through it, put it in the ground, and just keep, that's what they call stringing conduit as you go. Once you get that the conduit into the dirt, the string's fully installed, pull a rope in, pull your pulling cable in. That's the simple method of doing it right there. And probably one of the most least inexpensive ways of doing it. So that's a good method of pulling it. Okay. I want to show you one piece of equipment here that is probably a huge favorite out there in the world. When you have to pull a conductor and you pull your rope in, and you've got a rope in conduit, and that you're unable to push it through, and you're unable to pull it through by hand, we use these things often. Let me share my screen with you here. Okay, this is what they call a Sherman and Riley underdog. Now there's one piece, this one's they're being worked on. There's one piece where you have a fold out, what they call an elephant snout. So you're able to take this cable and run it out to here and put your conduit, put it right over the top of the conduit to be able to pull conductor in. So you strung your conduit, you pulled a rope in your conduit with the string. Now you take your rope and you attach it to this pulling cable, and you pull the pulling cable back through with the rope. Then you attach your cable that you're pulling in to this pulling cable on the machine. It's called a Sherman and Riley underdog. Relatively inexpensive, $25,000 for this piece of equipment. And it has a tensioner on it, so you know what the tension is. Then you're able to sit here with this machine and pull the conductor in with the Sherman and Riley puller. These things were very popular. We had one in each area, and then the contract crews started coming, and they brought their own. So these are ones that you're going to use out there in cable pulls that are too hard to do manually. All right. Next part of the book, it goes into termination of splices, and I've actually got a couple of videos here to show you guys on terminations and splices. So I'll just move right over to them. This is what they call a load break elbow installation by Hubble Power Systems. They are a great producer of elbows, and we'll talk about this and discuss this as we go through.
Train the cable into the final assembled position per transformer cable practices.
Now that's a great example right there, guys. How is he installing the cable in Conduit? How's he getting the wire in?
Pushing it.
Pushing it, yeah. There's a lot of rigidity. That cable is fairly rigid, and when you're using the correct size pipe, which is a 2-inch pipe, it's a great fit to keep that wire rigid, and you're able to push it pretty easy.
Train the cable into the final assembled position per transformer cable practices. Allow sufficient slack in the cable to pull the elbow connector at least 1 foot away from and in line with the center line of the mating part during the load break operation. To provide sufficient length of central neutral conductor for grounding after installation, measure 8 inches down the cable from the center line of the bushing interface and remove the outer jacket to this distance.
Okay, so the first thing that, the common error that people make here as far as getting ready to make their elbow termination right here is they think the end of the wire, as far as the measurement, is what goes on the module that we worked out there at the field. That's where I need to install my elbows, right at the end of the wire. You have to give yourself sufficient ground, and you all saw the grounds coming off the elbows, to reach the ground plus the elbow. So make sure that you skin off or take off enough outer jacket, and you're usually going to use just a skinny knife and a strand of the wire to peel it off. Make sure you have sufficient ground to reach the ground plus the elbow install. The elbow install is going to be way down here, and he's got enough ground wire to reach down to the ground.
Care should be taken not to damage drain wires. Twist neutral wires into a braid and connect to the ground with appropriate connector.
Look at that cool tool.
Make sure to provide sufficient slack in ground braid for elbow operation. Cut the excess cable off square and even with the center line of the bushing. Measure 2 inches down from the end of the cable.
Okay, so I'm going to stop right here. He's going to start getting into rulers and measurements. Both Hubble and Elastomold. That's another manufacturer of 15 kV or any other kV load break type elbows. Every single box or package that they come in now have a template. So all you'll have to do is put that template up beside the conductor right here and make measurements. Right, you're not going to need a ruler, and that template in every single package right there is precise, so you know you can use it. So these guys are going to be pulling out a bunch of tools and different stuff here. A template is included in the package now.
Which is down from the end of the cable, and remove the shield and insulation to expose the bare conductor. Cut squarely, making sure not to nick the conductor. Pre-assemble probe into the lug to verify proper threading before the lug is crimped to the conductor. Use a wire brush to clean the exposed conductor. Place the compression lug on the conductor and rotate to spread inhibitor. Make sure to align the flat threaded side with the bushing interface. Crimp the lug to the conductor, starting just below the knurled line and rotating.
Okay, so when you get this insulation cleaned off and you start crimping, where do you crimp? From top to bottom or bottom to top?
Bottom to top.
Anybody else?
Top to bottom.
Top to bottom. You start at the top here, and it actually makes this aluminum, and it's soft. It'll actually make the aluminum expand and crawl down the conductor. It's hard to see in this picture right here. There's actually, after he skinned it, a little bit of spacing for expansion. So you want to crimp from top to bottom. If you crimp from bottom to top, it's going to leave a bubble in it where it couldn't escape, that aluminum couldn't escape anymore, and you're going to have extreme difficulties pushing the elbow on. The elbow fits rather tightly.
Successive crimps to prevent bowing. Wipe excess inhibitor at the base of the lug and smooth any sharp edges on the crimps of the lug. Measure 6 7/8 inches down from the end of the lug.
All right, do we need to measure? What are we going to use that's in our package to make that measurement?
Use a template.
Yeah, you're going to just put the template right back up to it. It's going to show you exactly where you need to make your mark.
And remove cable insulation shield. cut squarely, making sure not to nick the insulation. Bevel the insulation end 1/8 of an inch. Refer to the seal kit instructions if the seal kit is used. Clean and lubricate the cable insulation and cable entrance to the elbow, making sure that each are free from contaminants. Use the supplied lubricant, as other lubricants can be harmful to products. Slide the elbow onto the cable using a back and forth twisting motion.
Okay, so we did see this in some cases out there, and we had some guys, contractors come in. The lubricant that he's putting on here, don't put too much. You just want a thin film of this lubricant, and you've got to use the lubricant that's in the supplied package. For some reason, I don't know why they did it. I guess they were just not really that competent. We had a crews come in that were contract crews that actually used gear grease. They used a petroleum-based grease. Put grease on the wire, then they put the elbows on. Well, petroleum and rubber don't mix, and those elbows quickly failed. You've got to use the silicone grease in the supplied package, and don't put it on over generously. A thin film. You put too much on, it's going to create an obstruction here to pushing the elbow on. It's going to be a lot more difficult to push it on.
The final seating of the elbow should align the elbow and threaded portion of the lug. Wipe off.
So he's going to do exactly what you need to do here. Remember, the eye of the lug that was on top was threaded. You need to get that in line with the elbow right here so you're able to thread the tip in. He's looking down at to see where his threads are.
Off excess lubricant that may form at the bottom of the elbow. Hand thread the probe into the lug to avoid cross threading. Once the probe has been properly started,
now you see this tool that he's using right here.
Use the supplied wrench to fully tighten the probe into the lug. The probe will be fully mated.
Okay, that is supplied in the package also. They do have other torque tools that you're able to use. They're a little bit pricey, but if you take the torque tool that's installed, this little wrench right here, once you put the elbow on and this bar starts to bend, you know you have it torqued correctly. So this is really a very basic torque wrench that you're using to tighten the tip into the elbow.
When the wrench permanently deforms at approximately 100 to 200 inch-pounds of force, attach a number 14 AWG copper wire to the grounding eye of the elbow. Twist the wire at least 2 turns. Attach the free end to the system ground.
Okay, this is going to be coming up also on a quiz later on. Saw a couple of you guys do it out there at the field, not very often, which is a good thing. Energized or de-energized, how do you install a load brake elbow onto any kind of insert? That's a feed-through insert. The one above is a 4-way module. We have standoff inserts. What tool must be used to install or remove elbows? You got to use a stick every time. All right, you will see some linemen, especially when it's de-energized, that will grab the elbow right here and push it on. If it's de-energized, it's not going to hurt you, but when you do that, you're putting stresses onto the conductor right at the tip, and it's going to degrade the tip. You've got to use a stick. A stick pushes all the force from the back of the elbow on and off of the insert that you're putting on. So even de-energized, you've got to use a stick to take a elbow on or off any kind of insert bushing. Okay, any questions there? I know that's short and sweet and easy, but really, guys, you're going to get your first underground elbow to make up. Somebody's going to help you out. If you throw that template onto the cable and take your time, the instructions are on the template. The template has the measurement, and it's just a regular white card that you're going to have. You're not going to have any problems as far as installing a load brake elbow. I think the biggest things to look out for here is, here's the main thing that people do in error. One, they think the end of the wire is where the elbow needs to go. No, you need to give yourself sufficient ground wire down here, then install your elbow onto the wherever you're going here as far as the measurement is concerned. Does that mean I need to pull extra wire out on both ends?
Yeah.
Yeah. I mean, I'd be so generous as to say, if I know I'm going to be installing an elbow, my elbow connection is going to be in this area down here. I'm going to pull about 6 to 10 extra feet out of both ends. So if this is going down to another transformer down here on the left-hand side, I'm going to have 10 feet of wire primary hanging out. On this side, I'm going to have 10 feet out. You know, just to make sure that I've got enough ground conductor. One, I'm able to train the cable into the enclosure. And just by chance, if I make a mistake, I've got more to work with. I don't have to pull the whole span again. So that's one of the most common errors that go into making up an elbow. The rest of it is all just by the book. Follow the instructions that you have going on in the book and make sure you get down towards the end here. Installation and removal is done by a shotgun stick.
Into the system ground.
Okay, you got to use a shotgun stick to install and remove load break elbows. Okay, any questions there? Does give a good example right here of how many primaries are going in. One inbound, how many do I have outbound? Two outbound, and I'm getting ready to install a fourth over here on the C phase. This was made in 2017, so it's got about 3 years on it. It's a little bit older of an enclosure, and that enclosure might be even older than that because of when it was installed, but it's still the same concept. Okay. All right, it's 10:32. That's for the splice. I need to go make a phone call here real quick. So we'll give it about another 10 minutes. We'll go to 10:42, take a break, and we'll be right back and we'll look at underground splices.